Every few years, a homeowner updates the house to keep up with trends in materials and finishes and keep the house up to date and modern. Likewise, as makers, we need to get into the habit of refactoring our code to streamline it as our project grows and make room for new features. Here is some code I wrote for a touchscreen display to use it as a keyboard controller. Now this code is already very long, about 300 lines. And I want to add code for displaying a clock, which then requires code for Wi-Fi connectivity, because we are going to use a web service to get local time. I also want to redesign the UI to show an analog clock and a keypad. If I keep going this way, my code is going to be like a bowl of spaghetti. Just very hard to keep track of what happens where and stay on top. I started refactoring into object-oriented code, giving each visual element, the analog clock, the keypad, its own class. So by pulling the code out of the main program and into classes, I can develop these classes independently outside of the main program. In the process, I learned an interesting lesson in using pointers in the C programming language. You see, while each visual element, the analog clock, the keypad, has a class of its own, they all share a common display. They are all rendered on the same physical hardware. So I need a way to pass a copy of the display object to each class so that the copies all point to one object. The way to do this in C programming is with pointers. So here I have a class for the keypad. The class has methods to draw a keypad on the touchscreen display, for calibration, and to sense touch, and execute callbacks, which are parcels of code based on the key pressed. Note that the touchscreen display as an object is a private member of this class. But I am not passing the object itself. Instead, I am passing a pointer to it, which is why I have the asterisk symbol. The asterisk indicates that instead of passing the display object, I'm passing the address of the display object and storing it as a private member of the keypad class. But it is not enough to just pass the address, is it? We also need to tell what is it that we will find there. And that is an object of the TFT underscore ESPI class from the TFT underscore ESPI module, where in the main program we had used this library TFT underscore ESPI to create an object like so. So this declaration gives the keypad class an address and also tells it that when it gets to the address, it will find an object of the display class. And since this attribute is private, we need to provide public getSet methods for access. I have declared a public method init that accepts a pointer to the display object to set this private attribute. Note that the interface by which this method accepts a display object is identical to the declaration of the display object as a private member. Now we will use this display object in the other methods of this class to draw the keypad, for calibration, and to sense touch and execute callbacks. So how do we refer to the display object in the class definition where these methods are fleshed out? So let's go to the class definition, the CPP file, and find out. So the way to refer to an attribute of a class within the class itself is with this variable. This is a self-referential variable, and we use it with the arrow operator, and then the name of the attribute that we want to access. But what is stored as the attribute is the address of the display object, not the display object itself, remember? So we need to use an asterisk operator to get the contents at the address, which is the display object. So having gotten the object, we can now use all of its methods in this keypad class to render our keypad. Now in the main program, We first create a display object. Then we create a keypad object. But we haven't linked these two together yet. So after initializing the display object, we then pass it to the init method of the keypad object. And since we are passing the address of the display object, not the display object itself, this time we use the AND operator to extract the address of the display object, which is then passed to the init method of the keypad. So this was an interesting exercise in using pointers to make classes in my project aware of each other. In this case, so classes for the different visual elements like an analog clock and a keypad can share a common display object.